In this video, we're going to learn how to solve a differential equation. So starting off with the slope, dy over dx equals secant squared x plus 2x plus 5. So now we have to ask ourselves, what's the antiderivative of this? The antiderivative of dy over dx has to be y. The derivative of what will give us secant squared? Well, that's tangent x, and the antiderivative of 2x is x squared. And the antiderivative of 5 is plus 5x. Now, whenever you do this, you have to add a c because there's millions and millions and millions of derivatives of this function that will give you the same exact answer. So we're going to put c because it could be 1, 2, 3, 100, 1 million, so on, so on, so on, so on. So let's do another one. Dy over dx equals sine x minus e to the negative x plus 2x to the fourth So the antiderivative of this would be y equals derivative of what will give us sine x. Well, it could be cosine, but derivative of cosine is negative sine. So this has to be negative cosine of x. And now the derivative of e to the x is e to the x, but if you have a negative, it's going to make it positive. So you can't start off with the negative because it's going to make it positive, which won't keep the same sign. So we're going to start off with the positive, and then we'll check these, e to the negative x. And the antiderivative of this will be, you have to add 1 to the power and then divide by whatever the new power is. So in this case, it will be 2/5 x to the 5th plus c. Now, my recommendation is always double check. So if you look over here, the derivative of negative cosine of x is sine x, and derivative of x is 1. The derivative of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1. So that's check. And now the derivative of 2/5 x to the 5th, that would make it 10 over 5, which is 2x to the 4th, plus c. So this has to be correct. So starting off with another function, the antiderivative, we're going to solve, Okay, starting off with another antiderivative, dy over dx equals 1 over the root 1 minus x squared minus 1 over root x. Now, this one's not so hard to get if you remember all your derivatives. This one requires a little bit of finagling. So you could write this function as minus negative x to the negative 1/2. And that will make it easier for you to solve. So the antiderivative of dy over dx is y, because the derivative of y is dy over dx because it's in respect to x, equals, now, which derivative will give you 1 over root 1 minus x squared? Well, that has to be the inverse of sine. And it's just sine to the inverse of sine of regular x. Now, when you do this one, you got to add 1 to the power and divide by whatever your new power is, so it's 1/2. So when you divide by a fraction, it's really flipping it and multiplying. So now you're going to get minus 2 root x plus c. That is the antiderivative of this, and if you take the derivative of this, it will actually give you that function. So now, the last one that we're going to do is a different function, which is du over dx equals secant squared x to the fifth quantity 5x to the fourth. Now, some people get confused with this, but you have to remember when you take the derivative of something, it's really a chain rule. So now you're using a new letter, du over dx, so it has to be u is the antiderivative equals. Now the derivative of what will give us secant squared, I believe we answered that in the first question that we did, which was tangent. But the derivative of tangent is secant squared, but you need to get x to the fifth, so it has to be x to the fifth. Now, let's see if this is true. The derivative of tangent is secant squared, x to the fifth. The derivative of the angle, x to the fifth, is 5x to the fourth plus c. I hope this helps you, and in our next video, we'll solve initial value problems.